There are only 3 ketones that are on my list of must-know structures for common names. Here they are. Acetone. It's the smallest ketone. It's widely used in the research labs and commercially. It's used in households. You gotta know acetone. Methyl ethyl ketone is the bigger brother. It's actually misnamed. The common nomenclature would say it should be called ethyl methyl ketone, but everybody calls it methyl ethyl ketone or MEK. It's used widely in industry. It's easy to know the structure because there's a methyl group and an ethyl group attached to the carbonyl. And the third one is acetophenone. If you've seen aromatics, you've seen this already. It's the simplest aromatic ketone. A benzene ring attached to the carbonyl and a methyl on the other side. Beyond the 3 you see here, there's a rule that lets you name lots of small ketones with the common nomenclature. You use 3-word names, naming each group that's attached to the carbonyl and putting ketone at the end. Those groups are supposed to be in alphabetical order, and that's why methyl ethyl ketone is misnamed. So let's take a couple examples. This guy would be called benzyl ethyl ketone. This aromatic ring with a CH2 here is the benzyl group, and this is ethyl. We'll put them in alphabetical order and call it benzyl ethyl ketone. Here's another example. This is the vinyl group. This guy is methyl. Methyl comes before vinyl, so we'll call this methyl vinyl ketone. And finally, when you have 2 groups that are the same, you can call it di something or other. Here are 2 phenyl groups, and I picked this on purpose to make sure you understand that this is called a phenyl group, not a benzyl group. It's a benzene ring that's attached to the ketone, but it's not called a benzyl group, it's called phenyl. So this is diphenyl ketone. 2 words. And here's the benzyl group. There are 2 of them attached to this carbonyl. So it's dibenzyl ketone. Okay, common names of ketones are really easy. Let's take a look at the systematic names using the IUPAC rules. There are 8 steps we should follow in this order. Let's take a quick review. First thing we do is identify the highest priority functional group in the molecule, and then we'll find the longest chain that contains that highest priority functional group. After that, we'll write the name that tells us the length of the chain using an alkane name, and then change the ending of the name to designate the functional group that we have as the highest priority. We'll replace the E of the alkane with some name like ONE for ketones. After that, we're going to name all the substituents that are stuck to the chain that we've identified as being the longest chain. We're going to place them in alphabetical order in front of the name. And then we're going to number the chain beginning at the end that's closest to the highest priority functional group. This will tell us the numbers of the carbons that have substituents on them, and we'll put those numbers in front of the substituents. The only thing left after that is to add to the name any stereochemical designators, R or S, E or Z. And there you have it. Following these steps in this order will get you the right systematic name every time. Take a look at these ketone examples. For this ketone, the highest priority functional group is the ketone. It's the only one in the molecule. And the longest chain is the 5-carbon chain we're looking at here. We'll call this a pentane because it has 5 carbons. And we'll change the E to tell us that there's a ketone as the functional group. We'll use ONE. Now, unlike aldehydes, that carbonyl group could be anywhere on the chain, so we'll have to use a number designator. We'll number from the end that's closest to the functional group, and that puts the ketone on the 2-carbon. This is 2-pentanone. This guy's a little different. It has a substituent and a second functional group. We need to know that the highest priority functional group is the ketone. Ketones are higher priority than alcohols. And when we name alcohols as substituents, we call them hydroxy groups. So again, this is a 2-pentanone. It has a hydroxy substituent. And when we number the chain, we'll number from the end that's closest to the functional group that's highest priority. And that puts this hydroxy group on the 4th carbon. Now we're almost done, but we have a stereochemical designator to put in there, either R or S. we'll use our Kahn, Ingold, Prelog rules. Looking at the 4 groups that are attached to this stereogenic center, this carbon, the highest priority is oxygen. The second highest priority is a substituted carbon. The third highest priority is this other carbon. And finally, we have the hydrogen. When we proceed from 1 to 2 to 3, we find ourselves going in a clockwise direction. But the lowest priority functional group is toward us rather than away. So this is not the R stereochemistry. We have to change our answer to be S. S for hydroxy 2-pentanone. Now what's different? Again, we have 2 functional groups. Now it's an alkene and a ketone. The longest chain that contains the highest priority functional group, which is the carbonyl, is a 6-carbon chain. So we're going to call this a hexanone. But because we have a double bond there, we're going to have to indicate it's an alkene, which means we change this A to an E, and we have a hexenone. Now we'll need to number the carbons so we can indicate where the ketone and the alkene is. Start at the end that's closest to the highest priority functional group. Because we have to number the alkene and the ketone, we'll have to put the ketone number directly in front of the ONE. So I've made space so we can say 2-one right here. And the number for the alkene can go directly in front of the EN, or it can go directly in front of the name itself. There's one more detail about this name. We need to assign E or Z stereochemistry to the alkene. To do that, we'll look first at the carbon on the left and see that compared to the hydrogen, this methyl is higher priority. And then we'll look at the carbon on the right, and compared to this hydrogen, this alkyl group has higher priority. Those 2 groups are on opposite sides of the double bond, so that is the E stereochemistry. And again, we'll put it in parentheses. So the full name is E,4-hexene 2-one. Here's another one. Unlike aldehydes, ketones can be in a ring. They're very easy to name. You simply name the size of the ring and call it one, cyclopentane, and then change the E to tell us it's a ketone. Because it's a ring, by definition, carbon 1 is where the carbonyl is, so you don't use a number. This is cyclopentanone. If there's something else going on with the ring, we can modify the name to show that. So this is a cyclopentenone. We'll change that A to an E right here. Pentene, so it's a double bond. One. Don't need a number. It's always going to be 1. We'll number the ring. 1, 2, going in the direction that gets us to the double bond quickest. So this is 2-cyclopentenone. Here's another guy. This has 2 carbonyl groups. They're both ketones, so it's a dione. The longest chain is 1, 2, 3, 4, 5 carbons, so it's a pentane. We need to change the E to show that it's a ketone. But since there are 2 carbonyl groups, we're going to call this a dione. We'll have to name the substituent. It's a phenyl group. We'll number from the end that is closest to a functional group, and in this case, since either end would be the same, we'll pick the end that has the phenyl group associated with it to keep that number lowest. So it's 1-phenyl, 2,4-pentane dione. These rules make a lot of sense. And finally, let's look at one aromatic case. We need to recognize that this is an acetophenone. It has the aromatic ring with the carbonyl and a methyl attached to it. So this makes it acetophenone. Be sure to notice this is methyl. So we'll call this an acetophenone. We'll number in the direction that gets us to a substituent quickest. We'll place the substituents in alphabetical order and stick in the numbers to tell people where they are. This is the 5-chloro-2-methyl acetophenone. And there you have it. These rules make naming ketones really straightforward.